Good morning and welcome to the release of the latest version of the world's most sophisticated building performance simulation software, eighties 4.8. My name is Lars Olinius and I work as product manager at EQUA. I have been part of the development team since 2004. On my side today is Alice Schulze. She works in the Swedish consulting team and she is an expert eighties user. In this webinar, we will take a look at some of the new features in eighties 4.8, which we release today. We are very happy about your interest in this event. You are a few hundred participants on the web, and we also have a number of people attending this webinar here live in Stockholm. So welcome to all of you as well. We have a lot to cover today, and so we will proceed pretty quickly. But don't worry, this webinar is recorded and you will get a link to the recording after the webinar. We would appreciate if you save your questions to the Q&A session that we will have at the end of the webinar. You can then either write your question in the chat window, which you see on the right, or you can ask questions by raising your hand. I now hand over to Alice, who will guide you through some of the innovative new features. Go ahead, Alice.
So I will start directly with my favorite highlights, and it is optimization inside eighties and graphical scripting. You might have probably noticed that there are several optimization problems in buildings, like which glazing properties to choose to minimize energy consumption and maximize daylight. Or what is the optimal flow in a borehole loop? Or how large should a hot water tank be for a solar thermal system or heat pump system? So there are many questions. And now it has become much easier to find these best parameter setups by using our new Parametric Runs interface, which you can find here under Tools. Tools, Parametric Runs. This. So we'll set up here a simple example which will help you to understand how this works. I have here a residential building. Actually, it's just one zone to make it very simple. And it has supply, mechanical supply and exhaust air ventilation with heat recovery. And the question I want to ask is, what is the optimal supply air temperature for this building? So which supply air temperature will give the lowest possible energy consumption? So this is the parameter I want to test. And as I am interested to minimize the total energy consumption, I have introduced a new meter, electrical meter, called All Energy. And I have connected all the energy users to it, as you can see it here. So now I will show you how I set up the parametric run case. So first, you need to choose what kind of simulation you want to run. And I have chosen energy simulation this time. And then we need to choose which parameter we want to vary. And this time we'll only have one parameter, but you can have as many parameters as you want. To add parameters, you either click on this button, and so you can browse the parameter in the model, or you can do it like I like to do it. I find the parameter in the model, right-click on it, and choose Add to Parametric Runs. So I have already added it, so I can't do it again. So to save time, we have to give some OK range within parameter can vary. So let's say that the minimum allowed supply temperature is 10 degrees and maximum is 25 degrees. We should also give some reasonable resolution. And this time I gave it set it as 16 because I want to test round numbers like 10, 11, 12, etc. So now I have to choose which result I want to optimize. So this time I want to minimize the total energy consumption. So I do it like that, like this. I go to the summary tab and search for my result that I'm interested in. And this time I will optimize this total energy consumption for my meter, all energy. And I right-click on it and choose Add to Parametric Runs. Yeah, I have already done it, so I will take it away. So now we are ready to run simulations. So if we press this button, Run All, and then all the 16 simulations will be run in sequence by using parallelization. And I have already done it, and we can view the results here. So if we sort it by all energy, we see that supply temperature of 15 degrees gave the lowest energy consumption. You can also make diagrams of it. If you press on this button, we'll show temperature to x-axis and all energy as y-axis. So now you can see very clearly that 15 degrees Celsius is an optimum for this building. Okay. So this all sounds good, but what if you're dealing with larger projects, which I suppose you do? And what if there are several parameters that you want to optimize? And that's where the parametric runs comes in. You see this button, optimization button. So it uses smarter algorithms, so it tries to eliminate those parameters setups that will obviously give unwanted results. We use now GenIPT, which is an optimization engine created by Lawrence Berkeley National Lab. And most of those engines works like that they start by choosing some random parameter setups. They just try some, and then they continue with best parameters until they find the best parameter setup. So here, what I have here in this model, I have an office building, just one story of it. And I have variable ventilation airflow in the zones, which is controlled by temperature and CO2. And I have no cooling units in the zones. So the spaces are cooled just by variable airflow and the cooling coil in the supply air. So the question now that I want to ask, what is the optimum supply temperature graph that I will use for this building? So my graph is defined here with 3 points, with outside temperature minus 15, 5, and plus 20 degrees. So I want to know which supply temperature at which outside temperature will be most effective. So now I have 3 parameters to vary. So that's how it looks like. Now I have 3 parameters. And if I want to run all the possible scenarios, it would be around 2,700 simulations. And it would take a lot of time to do these simulations. So here I need to use GenIPT. And here, as in previous example, I have chosen as a target output the total energy consumption. And I have also chosen the operative temperature of the worst zone that I only want to show, that I only want to see. And yeah, we can look at the results, what happened here. I sort it again, total energy. No, this. We see that, okay, this was a wrong model.
You're in the bottom, I think.
Yeah. It's my computer, which is a Mac, so the scroll is inverted. Sorry about that.
Sorry, I thought, oh, okay. But you see that the lowest energy consumption is achieved by having almost constant supplier temperature is 20 degrees or all year round. And I am not quite satisfied with the results because I see that the operative temperature in my room is almost 29 degrees. So this optimization doesn't make any sense. So I want to make a new optimization where I take the indoor air temperature as into consideration. So I have to build some kind of constraint function. And here you can use the other new highlight that we have. It's graphical scripting that I like a lot. So I will show how that works. It's how I build constraint function with graphical scripting. So graphical scripting you find here, and I think it has made scripting in IDEs much more fun or much more understandable. So it's the same optimization case. An idea that I wanted to do, I wanted to multiply my result, my energy consumption, with a very big number if the indoor air temperature exceeds 26 degrees in my zone. So I did it like this. I added the maximum operative temperature from the worst zone here, and you add it very simply. I do it from summary tab. You just right-click on some temperature and choose Add to Graphical Script. So you can just insert it here. And I have also inserted in the same manner the total energy consumption, you see here. And then I have inserted some other components like greater than and switch and multiplier. So what happens here? If the measured temperature in the room is about 26 degrees, then this component sends signal true, which activates the switch, and the switch will send out a signal 1000. So my energy consumption will be multiplied with 1000. And otherwise, if the temperature is below 26 degrees, then the energy consumption will be multiplied with 1 instead. And now I want to optimize this output result. So in this way, I will eliminate those results that give too high indoor temperatures. So let's look at results. Oh, I forgot to mention that here you can also choose when the script should be executed. And here I have chosen run simulation. I think it should be called post simulation. So the script is executed always after the simulation is run, because you need to have the results to do the script. And that's how it looks like. So you see that some results are very large down here, and it's because they had the operative temperature that is higher than 26 degrees. There's some mistake. I think we can take the other parameter. No. Yeah, this is better. And if we look at the diagram here, we can show this operative temperature as a color sense. And we see the wrong results, or the results that gave very high energy consumption. And then we see the results we're interested in. I will just change the scale. So we see what the optimization engine is doing. So we can see here, so it took 180 iterations to come to this answer. And you see that optimization engine is slowly finding the best solution that will give the lowest energy consumption. So, and what was the temperature? Yeah, so it's 20 degrees supply temperature when it's minus 15 outside, 19.5 degrees Celsius when it's plus 5, and around 15.5 degrees Celsius supply temperature when it's warm outside, 20 degrees. So this is the best setup for this building. And you can also use graphical scripting if you want to make relations, like dependencies between different parameters. Like in this case, I want to optimize G value for glazing. So I want to see which G value for each facade will give the lowest energy consumption. And that's how the parametric run looks like. So now I have 5 parameters. I have 4 facades and 1 glazed area that I want to look at separately. And here I used graphical script, which is executed every time I build the model. And here is the G values for all the glazings. And I multiply them with 0.25 in this case. And I map the multiplication to a T value. So you will see that T value here is gray marked, which means it's mapped to this parameter in a graphical script. So that's very convenient. Enough about optimization. I want to show another application for graphical scripting, which I like a lot. If you have worked with advanced level with schematic view, you might have noticed that once you are in schematic view and have done some changes here, you cannot do any changes in standard view. If you do so, you have to rebuild the model again. So now we can avoid it with graphical script. So we can do it like this. I have an office building here, little one with garage underneath it, 2 garage zones. And what I want to do, I want to ventilate the garage with return air from office. So I take the return air from office, blow it into 2 garage zones, then the air comes back from garage, return air here to this air merge, and then it goes back to air exhaust. And to do this, I have to do some changes in schematic view here. So I take away the existing supply and exhaust air connections for a garage, and I connect them to these interfaces I've created here. So return air, supply air, and for the other garage zone as well. Running out of time. Try to hurry up here. And next time when I want to change something in the general view, I have to rebuild this model and I have to do these changes in schematic again. So that's been quite annoying. So we can use graphical script instead, in a very neat way. So first I will use tools, diff script, to see the differences I have made from the last time I saved the model. We see it here. I just copy it, and then I go to graphical script here. Then I create a new one, like this. And then I drag in something called custom script here. And just open it and paste this diff script that I just copied. And the only thing I have to do here is just to put in a little system here, so the script is executed for a whole model, not just for this graphical script interface. Okay, so now I have a script, and I have to choose when I want to execute it. So I want to execute every time I build the model. So I choose build the model. So now I will do some changes in the standard level. And next time I will do a simulation. Or if I only want to build the model again, I will do it again. So we hope that our changes will be there. And the script is working. Yeah, you see, they have not disappeared. So that's nice. Okay, enough about graphical scripting.
We should also mention that the parametric runs and graphical scripting is available in the expert edition, but it's, as Alice has said, really cool features. That's why we wanted to show you that first, but we spent a little too much time on that, so we'll hurry up about the next things.
So I will continue here by showing you some usability and productivity improvements. Lars will show you later our new floor plan and improvements in 3D. But there are some other new features as well. Like now you can set separate construction defaults for walls and slabs facing ground, and for hanging external walls that aren't connected to ground as well. So this will speed up modeling in many cases. Other thing that you can now use slab heating and cooling even in vertical walls. Like this. Another little bit nice thing is the water radiator that has got a new simplified form, as you see here. And you can now insert the radiator power in the table for room units, like here. We have also fixed the multiple selection in tables, so it's easy to mark many components at a time and, for instance, delete them. Furthermore, it's possible now to remove all unused resources from resource container. So it's nice to get it clean sometimes. If you're logging variables, you can see now which variables are logged to which output file. So there's a new column for it. So if I choose to log this to some output file, I can see it here. You'll probably discover some more things when you start working with your IDEs. So I will proceed with my next topic. Next thing I want to talk about is about thermal bridges. And there is one tricky thing about thermal bridges. I will just open the model. And this tricky thing is linked to building envelope that can be measured in several different ways. So mostly used are overall internal or external dimensions. And this means that there are also different ways how to define losses due to thermal bridges. And these definitions, they vary depending on country and sometimes even project. As you might have noticed, we have used internal dimensions in IDEs. And the reason for that is that we work with zones where internal dimensions are essential. And this means, so unless you had C values for thermal bridges given for internal dimensions, you needed to adjust the values you insert in IDEs in some way. For instance, if you got C value for this connection, internal slab, external wall, for overall internal dimensions, then you needed to increase the C value to take this little wall part into account. So it's been a bit tricky, and some of our customers have even chosen to model their zones with paper-thin walls, so they avoid this problem. But now, instead of adjusting model or C values, you can choose between 5 different thermal bridge definitions. See here. And so you just choose which definition you want to use. And what is good as well, that you can now see the chosen area definition in the 3D. I'll do it like this. So if we go to 3D and put on wall thickness, now you see that internal dimensions are used because we have these gaps between zones here. But if we change to overall internal dimensions or external, these gaps will disappear. What is also good to have in mind is that even envelope area for the model will change depending on the area definition you have chosen. So if we switch to Zone Totals tab, where we can see the envelope area here, so you see that it changes when we change the area definition. Another thing, it's good to know that we have adjusted the values we call typical, so it's used to an ISO standard. Okay, enough about thermal bridges. So we have introduced also a new simulation type, which I think will be appreciated amongst many of you. And this simulation type is for overheating studies. And some of you might have used the existing cooling load simulation to do even overheating studies. The problem there is that this type of simulation is meant for sizing of cooling equipment. So all the results, temperatures, PPDs, etc., are presented at the time point with maximum heat removal. And it didn't make any sense in buildings without mechanical cooling. So now you can use this new overheating simulation that looks like this. So you can choose the variable of interest, if it's mean air temperature or operative temperature or PMV. And then, similar as in cooling load simulation, the critical months for chosen variable and for each zone will be saved, and all the results will be presented at the time point when the chosen variable peaked. So if you looked at the results, yeah, I haven't saved them. You can just run one simulation to see how it looks like. Yeah, so you see that all these results, PPDs and airflows and so on, are shown for this time point when maximum temperature occurred. There's also one new thing for new cooling load simulation that you can choose between max heat removed, like the total heat removed that we had before, or you can also choose to look only at room unit cool. It's good to know that we have a new model for heat emitted from occupants, which will have some influence on your simulation results. I don't have time to explain this in detail now, but the main point here is that the total heat emitted from occupants will be equal to the given metabolism, which wasn't always the case before. And I want to clarify that this change only applies to the calculation of heat emitted from occupants. So the calculation of PMV, PPD is not affected. Okay. Next thing I will talk about is our new enthalpy wheel exchanger. Now I will open some model here. Okay. Doesn't work.
Maybe it's not saved. Did you move it?
Yeah, I moved it, but
so probably it's saved in the old way.
Yeah, it's always technically it doesn't
find that.
Doesn't work. Okay, doesn't matter. So if this new enthalpy heat rotary heat exchanger can transfer both heat and moisture, which is the sensible and latent energy, and if you want to use it, or one way to use it is to replace the existing air handling unit to enthalpy wheel unit. See here. This is how it looks like. So this model is based on European standard, and has three options with different types of coating. So first type is untreated, which can transfer moisture only if condensation takes place in the wheel. Even our old standard heat exchanger took condensation into account, but it only transferred heat and no moisture. The second type is hygroscopic enthalpy wheel, and this type of heat exchanger can also transfer some moisture if there's no condensation in the wheel. And the third is the sorption, the second wheel, which is very effective when it comes to moisture transfer. So what happens in a model? In the during winter time, when spaces are in heating mode, and the outside air is cold and dry, the moisture recovery will help to increase the relative humidity in the zones, thus improving comfort for occupants. During summertime, it's the other way around, so the outside air is warm and humid. So incoming air that's passing through the wheel will be dried, dehumidified, and this can also improve the thermal or the comfort of the occupants. But the main thing it does, it dries the air, which means less condensation in the cooling coil here, which means less energy consumption. So you can actually save energy, cooling energy, by using this kind of enthalpy wheels. Yeah, and last thing for me is about PCMs, phase change materials, that can now be used as layers in walls and floors. So I will just open two models, one with PCM, one without PCM. So what is phase change materials? They are substances that are capable of storing large amount of energy by changing their phase. And most common PCMs that are used in buildings change between solid and liquid phase. So when temperature rises in building, then the PCM material goes to liquid, and thus absorbing a lot of heat and helping to reduce the cooling load peaks and the temperature peaks. And the other way around in wintertime, when the temperature drops, the PCM turns into solid and gives away heat, and thus reducing the heating power and minimum temperatures. So how you can use it? I have two models here. I will do it like this again. One with PCM, one without PCM. And in the model with PCM, I have just replaced one layer of gypsum to this PCM material. And you can just add new PCM material here. And I have done the same thing for the internal walls as well. So I've exchanged one layer of gypsum to this PCM. And otherwise, it's exactly the same model. So if we look at results here for an energy simulation, then we see that we have actually managed to save a little bit cooling energy here, and a little bit of heating energy as well, and a little bit of peak demand as well. So you get larger thermal mass for the building if you use these PCMs. I don't know if I have time to look at something else. I can just quickly show you the temperature comparison for these two cases. No, I will drag this mean air temperature instead. So the red line is mean a temperature with PCM, and the blue line is without. If we look at the winter case, we see that we have actually managed to decrease or even out the temperature a little bit more in the case with PCM. And if you want to look at the enthalpy for the PCM, it looks like this. So that's where the melting occurs. And this overline is where the solidifying occurs. Okay, thank you.
Great, thanks, Alisa. You'll hear more from Alisa when we come to the Q&A session at the end. And as I said in the beginning, we have a lot of things to cover. So, and we have quite short time, so maybe too short. But I'll be as quick as I can. So, another new feature of IDICE 4.8 is regarding the window model. We have two different window models in IDICE. We have a simplified window model where you can enter parameters for the whole glazing, and we also have a detailed pane by pane window model. And that's what we are going to look at right now. So we have updated this pane by pane window model with spectral calculation. So when manufacturers manufacture glazing and shading material, they measure these the properties of these in different wavelengths. Earlier we used to, and that's a common way to do this, is to calculate the combined properties of all these different spectra, and then calculate the properties of the whole pane by pane combination. The problem with that is that you cannot capture the nice features of modern glazing and shading material. So now we do this totally spectrally. So we take advantage of the fact that we do have spectral data for some of this glazing and shading materials. And we don't invent this data, but we have a cooperation with manufacturers of glazing. Right now it's Saint-Gobain that we have on board. And for the shading material, we have a large number of different manufacturers. And in this case that we're looking at here, we have the specific properties of this is that this first pane, which is on the outside, it stops some of the solar coming in, so that you don't get the glare effect, and it also stops some of the heat. And this inner pane, it stops the heat from going out when it's cold outside and warm inside. And together with this shade here, a roller shade, which has also very spectral properties, you get quite an interesting combination. In fact, it turns out that you can get the same properties with this combination as you could with an external shade. And that you can save a lot of money if you don't have to build external shades on buildings. But let's take a look at the difference with the spectral calculation. So we have, for comparison, we have a non-spectral window here, and it's still the same pane, and you can see that it's spectral by this little icon here with a rainbow showing the different colors of the spectra. But here we have created a variant of the shade that doesn't have spectral data. So basically, this will not be spectral. And we can just do this ISO 15099 calculation of the properties of this combined glazing and shading. And we get these properties. Unfortunately, we have to close this when we open the next, because I will compare, and this is a modal dialog. So I just save this as an image. So we'll take a look at the window with spectral properties and do the same calculation. And then we will see a large difference in the solar heat gain. And you see that there's a 25% difference here, which gives this a quite extraordinary properties, which you couldn't capture without this spectral calculation. We have also added more shading types of integrated shading. So this combination where we have panes and gaps and shades, you can, as you did in the last version, you added, or you have been able to for some time to add shadings inside this combination. But in 4.7, we added this easier way of defining shades. So we had the interior and exterior shades, but now in 4.8 we also added shades between panes. For instance, the Venetian blind between panes, which is very common in Scandinavia, for instance. And the way that works is that it places this Venetian blind in the middle of the largest gap in this glazing combination. We also have a brand new type of shading, which is called microlamella. And that is basically a film that you glue onto the, let's look at the database actually. So we have, for the microlamellas, we have a cooperation with a microshade. So they have their data here for their films, and what they do, they glue this film onto the pane, and what this really is a Venetian blind in miniature. So in this film, there is a structure with holes with some geometry, which is angular dependent, same thing as the Venetian blind. For the Venetian blind, we actually simulate every part of the Venetian blind, but here we have a file which accommodates for this angular dependence. And this can be used now in IDICE 4.8, and this can also be used in the daylight extension where we do the radiance calculation, and we also have radiance calculations for this microshade where we also have this angular dependence. We can take a look at some of the new features actually of the daylight extension. The daylight extension is included in the expert edition, and it's an you can buy it as an add-on to the standard edition. And we have made some updates in 4.8. We have changed the radiance parameters slightly, and we've added, we made high precision the default, and we've added a super high precision because we've noticed that these more low precision, although they're fast, they are not accurate enough in many cases where you have long paths of the sunlight. So we've added that. We've also made it possible to select the zones from a list instead of from the 3D view. You can still select it from the 3D view, but it might be sometimes easier to select it from a list. We've also added the median daylight factor as a result, which is used in some countries as a daylight measure. We've also added, well, we did have the ground earlier, but now we also show it when you visualize properties. So you can see the ground here, and if you visualize the reflectance, this you should always remember to do when you do daylight calculations. You should look at the geometry that we actually send to the radiance calculation. And here you can see that the ground is also sent with the correct properties. And we could also take a look at the results. So we'll go to animation, daylight factor. We've actually added another option of color here when you visualize results in 3D. You have here, you can select different colors. It's really continuous scale, but you select 3 different colors. Let's just put some values here on the limits, and then you get a color scale that's common in some common for visualizing solar radiation. And this new color scheme is actually also available for any of the properties. So if you, for instance, look at the constructions and surfaces, you can also change the color here. So for instance, you just double click or right click and choose properties, and you can select the different color here too, if you would like to have a nice looking picture for your report. And another new feature on the daylight tab is that when you click the control key, as before, you get these limits. You see here which daylight factor this limit is, and then you see what is above and below. And earlier you've been able to see the percentage, but now you can also see the area, which is below and above. And another feature for the daylight calculation is that you can now easily add 3D geometry right here in eighties. You don't need to import this anymore. So I just add an extruded geometry like this. I can edit it like any 2D feature. You see it here in the 3D view. I can assign a material, and I can change the height and the distance from the surface. So now it was cut, that's why you don't see the top of it, but now you see the top. That's very good for creating obstacles for the daylight calculation. It has no effect, though, on the eye-to-eyes calculation. But for the radiance daylight calculation, this will extrude. This extruded geometry will be an obstacle for the light. And one of the major updates for those of you that have used earlier versions of eighties is probably the new floor plan, which works very different from the last version. It looks different, and it has some more features like mouse wheel zoom. So let's import quickly. I don't have much time, but let's just import a DVD so we can take a look. So what I want to show you is actually the snapping, which is the main new functionality here. So we have a totally different type of snap in floor plan, so it's easy to find the correct lines. Oh, so when I approach the lines on the drawing, I see snap lines extending all the way to the end of the floor plan. And if I edit this, it might be more clear to see how you can see these snap lines, and it's quite easy to zoom in and add points in exactly the right location. So it's much faster now to create detailed geometry in floor plan. And another nice feature is the rotate view to align. So I select an edge, I click rotate view to align, and then it's very easy to add zones aligned with this. So now I can create these shoebox rooms that we need for the climate zone model quite easily in the correct place. And so Alice ended with showing beta feature. I don't know if you mentioned that PCM was a beta, but it's in beta version still. As always with beta versions, you need to use them with caution. You should report bugs, and there will be bugs, but please use them and try to find the bugs that will help us to have a final release version of it. Another new feature in the 3D view is that you directly in the 3D view can add shading buildings and horizontal shades. So you just drag them in like this, and you can choose edit. You get these editable. You can add new points, and you can edit this. And you earlier had to do this on the site plan, which could be quite small and difficult to work with. And here it's easier to see what you're doing in the 3D view. And Alice also talked about graphical scripting, and general scripting we've always had in eighties to write something that we call Lisp scripts, which is very difficult to understand for many people who doesn't know Lisp, of course, and that's why we did the graphical script. But we also have added another feature, which also is in beta version. That's an application programming interface to IDEs, so you can control IDEs from the outside. So you can basically do most of the operations that you can do inside IDEs, you can do from a remote program like MATLAB, Excel, or program language like C++ or Python. And this can also be done remotely on cloud machines using socket communications. This library of functions, this API is following the document object model standard, and it can be tested. It's available in the expert edition, but running. It's not possible to set up simulation servers. So if you want to run simulations remotely, you need a separate license agreement from us. Another feature that is in beta is CFD. And CFD works in the same way as Daylight. So it's basically sets up geometry and boundary conditions for an external tool called OpenFOAM. And this has been in beta versions for some time. We have been very restrictive with giving this for you to beta test. With the prerequisite has been that you should know other CFD tools, because we're still in the process of gathering feedback and implementing new features that we want to include. But now during 4.8, we will release the CFD as a public beta for all of you. It will still be a beta. And when we do, we will let you know, and we will have a webinar such as this to talk about CFD and the new features. Okay, so we're basically out of time. We had to skip some of the new features, but you can find most of them on the highlights page that you find on our web, and all new features are available in the changelog that you will get once we have sent out the download links to the new version. So let's do some Q&A, and we'll start. If anyone of you have a live question, we'll do that first. You just need to raise your hand, and we'll give you the microphone. Otherwise, we'll answer some. We have a few written questions so far. We can start with the written questions, since we don't have anyone raising your hand yet. We actually do have a raised hand here live. So,
okay, when you do the parametric runs, will you be able to examine like heat balances and stuff like that for each run, so you can examine why you get a specific result?
Yeah, you can choose, I think, to save the results or not. Or have I misunderstood it? But no, I was pressed wrong.
Maybe I can answer that question. Yes, you will be able to. I mean, basically, IDA needs to have a single scalar result to be able to optimize with respect to. So if you have a curve of things happening, like a temperature variation or something, then you'd have to use you have to build an advanced level, and you'd have to log that signal, and you have to snap to the maximum or minimum, whatever part of that curve you want to do. And then that variable that holds the snapping, you could add to the parametric script.
And that question was answered by our CEO, Per Salin. Any more live questions here in Stockholm? Not on the web either. Let's do the written questions. So we have a question about PCM, how to set up the PCM temperatures for melt and freeze.
Yeah, it's quite simple. We add a new PCM layer here. So here you see the enthalpy differences for different temperatures, delta T's. So you can just adjust these and make your own PCM materials. So yeah, that's easy to be done.
Okay, thank you. Next question is a question about the daylight simulation. And the question is there an opportunity to run annual simulation? Because the latest in 4.7 just simulated 1 day in the year, and that is still the case, unfortunately. We do have, there are ways of running in a yearly simulation, but it's very tricky to do this in IDA, but we do have instructions how to do it. But it's very early beta, and it's possible that it doesn't work in many cases. But we will definitely do development on whole year daylight simulations, but not in 4.8. What is the release date of 4.8? The release date is today. Unfortunately, we just noticed a problem right before this webinar, so otherwise it would have been available to you right now. I can show you how what I meant to show you, if it would have been available right now. So if you do have a maintenance agreement and you start IDICE 471, there's something that we call the portal, which some of you probably have turned off already because many people consider it a nuisance. But you can turn it on again in your option preferences. And this is quite a useful page. So we kind of want you to keep it turned on. You see the forum questions, you have your latest projects that you've been working on, you have support information, and you also have information about the editions you're running. And right now, the latest official version is 471. When we get this build ready, we will change this to 4.8, and this will show up red here in your 471 version. And after export here, you will get it will say download or upgrade. I think it says upgrade. And if you click that, you get the link to the actual installation file. So you can do that before we send out, but we will also do mailings. But hopefully today, that's the release date is today, but hopefully we'll get it out there today. So let's start. So the next question. If I create a new component and add in the schematic interface, after that I change something in the general tab and create a new model again, will my new created models still be there?
Yes, I think it should work if you use this graphical script that I showed you during the webinar. I suppose it should work.
You probably need some more instructions to show how to capture this script. Maybe you can repeat that. I'm not sure if it's...
Yeah, we can do that. So
no, maybe not right now, but
okay.
we can put that on the forum.
Oh yeah, that's a good idea.
Yeah. There's so many new things that you can do with this graphical scripting. So we'll put a lot of that on the forum as we go along, and as you start using this. And you're also always welcome to share your own scripts with other users. There's quite a lot of the old-fashioned scripts there, but the graphical scripts can also very well be shared. Can you optimize of the PCM to choose the melting temperatures?
I haven't tried it, but I think it should be possible. Probably a little bit tricky. Per has something to say here.
I think that would, this is Per Salin again, that would require that you actually parameterize a whole product description of a PCM, including the hysteresis. There's quite a lot of points on a physical PCM curve that needs to go into this database that Alice showed. So I think it's probably hard to optimize that automatically. Then you'd have to invent some sort of simplified PCM, which just has a few switching points. Then it could probably be done.
Thank you.
Can models in 471 be able to run in 4.8? Yes, we always have backwards compatibility. So any old models can be opened in newer versions. Unfortunately, not the other way around usually. Sometimes it works. You get questions about that this model was saved in a newer version, and then you have to accept things. But it's not guaranteed to work in the other way around. And will it be possible to split zones that are not cubical, for example, in non-flat roofs? Yes, the splitting of zones is something that I didn't have time to talk about right now. That is also in beta still. You can split zones with slabs or with walls to create smaller zones, so you can merge zones together. So what was the question?
This one. Or which question?
You removed that question, but yeah.
Like non-cubic.
Yes,
cube,
yes,
like.
exactly. You can I can't guarantee that everything works right now in this beta version, but eventually you should be able to split any type of geometry. So the idea is that you can import a complicated geometry and you can split that into floors and zones. So we'll eventually probably do some automatic zoning of buildings. We have actually reached 11 o'clock. We will continue answering questions as long as there are questions and attendees. But for those of you that have that need to leave, we thank you very much for participating in this webinar. And as you know, you will be given a link to the recording of this webinar, so you can look at these things again. And as we said, we will continue answering questions. You can look at that as well. Is there possibility to show the results of the daylight factor in the 3D view in a grid system so that you can see the actual results on different measurement points? Yes, it is possible, and it was possible even in 4.7. See if I can open this with the daylight results. So let's look at the daylight factor, and then there's an option smooth. If you unclick that, then you should show this. Maybe we had very many points, but if I zoom in here, you see that you have discrete squares here, and they correspond to the middle of these or the actual points. And if you move the mouse over there, you can see the actual value for each of these squares. Okay. Does room still have to be completely box-like for climate calculations? Yes, they still have to be shoebox rooms, and it's easier to add them now when we have this rotation in floor plan. Those of you who have attended sessions here during the years know that we are working on a new zone model, which where you can do these detailed calculations, view factor calculations that they're called, with arbitrary geometry, but that will be for the next version of eighties. Does ASHRAE work in version 4.8? Yes, ASHRAE will. We will. All extensions will be available, of course, with the new version. So all of them might not be available to start with, but we'll let you know which ones will be available right now when we do the mailing. PCM was earlier an add-in, but now it has been integrated. Will HM wall moisture buffering also be added now? No, it will not be added in 4.8. IFC import works now without simple BIM. Well, it has always been possible to import IFC models without simple BIM. It depends on how the IFC models are set up. It's if the architect know what we demand for the IFC model, it's possible to export IFC models without simple BIM. But we constantly do changes to the updates to the IFC import, and we have made some changes in 4.8 as well. So it hopefully works a little bit better than 4.7, but still simple BIM is a very good tool to quality assure and modify your IFC models. And those. Oh, we have a live question from Christian Wittrup. Please go ahead, Christian.
Is it possible to investigate the daylight factor of 3% in half of the time in half of the area? Because that's a new regulation for the Danish building legislation.
Half of the time?
Yeah, half of the time as when the occupants is there.
Yeah, the problem is that we don't have any time-dependent daylight factor calculation. We only calculate the daylight factor on specific time points. So to do that, you need some whole year daylight.
Yeah, some kind of UDI.
Yeah, exactly.
Is that a thing you're thinking of implementing in the new beta version, or is it possible to make a script that can take that into account?
Well, it's always possible to do a lot of radiance runs. It's not very efficient. The thing you do when you do whole daylight calculations is that you simplify and you do some representative solar angles, and then you interpolate between these to get the daylight factor for each time point. But you can of course, do a lot of radiance runs, but it will be very time consuming. And you can do that with a script, but it's not very efficient.
That's a pretty hard demand that we have to prove now in the new Danish building regulation.
Okay, yeah, that's good to know. We will, and we are investigating how to do whole year daylight simulations in the next version, but not in 4.8.
Okay, thank you very much.
Thank you. Any more questions? We have a written question. Is there instruction somewhere for architects on how to make their IFC models ready for eighties? Yes, we do have instructions on EQUA Online, which you find from the help menu. Support, download an info center. If you go there and you go to documentation, there's a section on IFC here, and there you can find information of what we demand for the IFC import. Any more questions? No? So we've spent 8 more minutes. We have a new question. With the new daylight model, is it possible to calculate different reflections from outside areas, like reflectant buildings or reflectant roofs? Yes, in the daylight calculation with the radiance, you do take into account all surfaces on the outside with reflections and all properties that you can set. But you do need to set the correct properties on all surfaces, of course. Okay. So thank you very much for attending this webinar, and we will work hard right now to get this build ready for you to install, and we will let you know as soon as it is available. We'll mail you, and we hope to see you on the next webinar. So
thank you for making such a good presentation, Alice and Lars.
Thank you. Bye.